Hi everyone. What we looked at recently was a refresher on basic probability. So what we're going to do is we're just going to ramp it up a gear. And what we're going to look at is something known as binomial distribution. So binomial, you can think of that as maybe bi being related to two things. Like think of binary, ones and zeros, or the state a light switch can be in, on and off. So nomial, well, it actually means or can mean terms. So looking at things with two terms, if you think back to your maths days, you might have heard of polynomials. So poly was many and not a parrot. So polynomial, many terms. Binomial, because we're dealing in probability here, instead of terms, we can think of things that can actually happen. So we can think of outcomes. So we're dealing with things with two outcomes. And you've actually seen that in the past, where it could be win lose, pass fail, driving test, etc. Or in an experiment, success or failure. So there's only two ways things can happen. Right, so previously we did use like games of chance to highlight this. So here, we've got a dice or a die. I know technically it's a die, but both are fine for me. So dice or die. So what would be the probability of getting a number one to land with one throw to land face up? Just like the picture is showing you there. If you can make that out as a dice or a die. So we've seen before, like the loose definition was if the favourable outcomes, the thing you want to happen, over the total number of outcomes. Basically here, the dice could actually land in 6 different ways. And this dice here, just to clarify, the faces have got are numbered 1, 2, 3, 4, 5 and 6. So there's only one face which has the number 1, so that's our favourable outcome. There's only one of them, and the total number of faces is 6. So we've seen that previously. So our probability of one landing face up is 1 in 6. So what would be the probability of you not getting a 1? Well, that's basically the 5 other sides out of the 6. So here the probability of 1 plus the probability of not 1, that little line above it, that negates it, or it's not. So here, that's a 6 plus 5, 6, and lo and behold, we've seen before, all probabilities should add up to give you 1 here. Fine, so we looked at that before. Things aren't always as simple as that. So we're saying here, if you roll the dice or die 12 times, or throw 12 simultaneously, what is the probability of the number 1 again, sticking with the picture, landing face up, what, exactly 7 times? Right, so here, we're rolling it 12 times, or throw 12 of them, and we want our favourable outcome to be the face with number 1 in it, but only getting 7 of them, exactly 7. Right, but what we're going to do here, because things can become a bit complicated, we're going to look at another example. So this is an example that's in the exercises. So this other example, we're talking about Tommy. He's a local whiz kid at pinball, and he has a 90% chance of winning a game against an opponent. Okay, so that would mean he would have a 10% chance of losing. So they take it in turns to have a game against each other. Oh, there's never a draw here in pinball. So just to show you, it's Tommy, the pinball kid. Right. So just to want to emphasize here, 90% chance of success, 10% chance of failure. Only 2 things can happen here: success, failure, win, lose. And again, probability of 1 probability of losing 90% plus 10%. Hopefully you get 100%. Converting that to a fraction, 100 over 100, which is indeed 1. So, like we've been saying here, only two things can happen here. So that is a binomial situation. But here, what if we change it? In the question, what is the probability of Tommy winning? Exactly. I'm not putting that word, but I just want to throw it in there. Exactly 8 out of 10 games. So you can have a wee think about that. Well, the probability of a win is 90%. I've just decimalised it there, 0.9. I could have written that as 9 over 10. So that means probability of getting 8 out of 10 should only be 8 out of 10. So as a fraction, probability of exactly 8. 8 out of 10, 8 over 10 times 0.9. So that's 0.8 times 0.9. Or is it? Yes, it is. Something like that there, 0.72. That would be brilliant if that was the answer. Like I said, I wish it was. Then we could all go home. But the thing is, Tommy, he can win his games in different ways. As long as he gets 8, he's happy. Well, I think he would rather have 10. But we've chosen 8 for some reason. Here, you can see the letters there. L for lose and W for win. So he could actually lose the first 2 and then hopefully win the remaining 8. So he could win it like that there. Or he could win the first 8 and lose the last 2. But he is still winning 8 out of the 10. Or win the first 3, lose the 4th. Win the next 4, lose the 9th, and then saves the day and he wins the last one. But he's still winning exactly 8. I'm not going to go through every scenario here. I'm just going to tell you there's 45 different ways for Tommy to win exactly 8 games. So I've thrown in the word there, exactly. That's going to be an important word for us. So, like it's in here, we want to clarify that issue. How did we get 45? So we're going to look at a simpler example and just see if we can get a handle on the situation. So a little example here is we're going for a bag. It's got 3 coloured balls in it, which are red, green and blue. There you go. Red, green and blue in a little transparent bag. Okay, I'll get rid of the bag. So what they're asking us here is, in how many ways can we select or choose 2 balls from the 3 in the bag? How many different ways? That word choose, that's going to be very, very important for us. So, and it's 2 from 3. So let's bring the bag back. Okay. Put the hand in the bag, pick out the first ball. It's red. Go back into the bag and select one of the 2 remaining balls. We've got a green. Stop there. Pretend we've put those balls back in the bag, but we've just registered them. So I'm going to leave them there. We're just registering them. Right. Go back in and pick another ball. Oh, it happens to be red again. So if we go back in, this time we've got a different colour. So that looks as if first row, second row, they're actually different from each other. Because we've got a red and a green at the top, a red and a blue on the bottom line there. Let's go back in. We've chosen red twice, so let's go back and get a different colour. We've got a blue, and you can see green has only been chosen once out of 5 there. Just bring that out, and we've got that there. I just want to point out that the order in each of the rows, it's unimportant. See that top line there? You can see you get a red on the left, a green on the right. If they were sweets, I don't want to encourage eating sweets, but if they were sweets, as long as you get a red and a green and a red, that's the same for you. Okay, so what we've actually got, how many ways can we select 2 items from a total of 3 items? there's actually 3 ways. So I didn't want to go through this scenario with Tommy and have 10 balls, 10 different coloured balls, and select 8, because I would have 45 rows and we might lose the plot. And I don't know if I've got that many coloured pens in my pencil case. Okay, so I mentioned the word choose, so we're going to look at something called the choose function. It actually looks like that there. So it's an n over an r and an elongated bracket. So it's actually defined as that horrible looking thing there. But you can see you get a fraction. N and R appear twice, and you get these little exclamation marks, whatever they are. But N is the total number of items, just like with 3 balls in the bag, and R, we wanted 2. So that's our choice of number, or item, whatever the thing we're looking at, whatever the story is, the scenario. So those little exclamation marks, in maths, we refer to that as a factorial function. A function does something, it's a process. So that there, n with exclamation mark, we call that n factorial, or factorial n. I'm not going to give you expanded definition with n, because letters just appear everywhere. So I'm just going to select a number here. So for example, I'm just going to choose 5. I would treat that as 5 factorial, or factorial 5. Its definition is you take the number 5, and you just start multiplying it by the number directly below it. So we're going down one step to 4. So it would be 5 times 4, then times the number below that, which is 3, then times that the number below that, which is 2, and finally times it by 1. Stop there, because if you went on to multiply by 0, you would wipe out the whole lot. The total would be 0. So here we go. 5 times 4 times 3 times 2 times 1. 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1, it doesn't change it, so the answer is 120. There you go. Let's pick another number, a smaller number. So pick 3, so that's 3 factorial, or factorial of 3. So that should be equal to 3 times 2 times 1. There we go. 3 2s are 6 times 1, again it's 6. Doesn't change it. Right. I'm showing you the factorial function because it's going to come in one of the other probability distribution functions, the Poisson, whatever that is. So, and we'll find that in the calculator. So when the time comes, we'll show you it. But that was the old-fashioned way that we calculate the choose function. So this choose function is involved in this thing called the binomial probability formula. But I want to go back here because I want to speak about the choose function. We don't want to use that formula, okay, because things have advanced over the years. We want to go and see if we can find an easier method. So in this set of notes here, I've just put in a wee explanation of this choose function. So there, you can see there that explanation that we had there. Okay, and I've just put in here as an example. But the thing I'm interested in to point out to you, let's make that a little bit bigger so you can see it. Right, I've got a Casio calculator for whatever reason, and so I'm going to use that to try and highlight things. So, can you see here? I'll try and hover the mouse. I don't know if you can catch that. See how I've got N, a big C and a small r? That's from my total N. You can choose R objects. And see that arrow's line? It's going down to the diagram there. See how where my cursor's over it? So it's above the divide sign in this calculator. I'm also going to need a shift key. See how my cursor is going onto the left diagram? So we're going to use that. So And so my instructions that I'm giving you here, you would put in your first number, whatever that is, press shift, and then divide. So your first number will be on your display, and you'll have the big letter C in your calculator. If you could, in most calculators, that's the way it will come up. Now put in your second number and press the equal sign, or the equals key. But in your calculator, before you press the equals key, we're going to actually use, right, we'll go for this, we're going to use 5 and 3. So I want to choose 3 items from a total of 5. So if I just put in my first number, okay, put in my first number, which I'm seeing is 5. Right, so I'm putting in 5, hit the shift key, and it should read 5 with a big C. Hit in my second number, which is 3. Okay, so on our calculator, or on my calculator, it should come up like that there. C5, C3. Right, hopefully you can see that. Once you hit the equal sign, hopefully you should see that there on your display. Let me just make that a wee bit bigger so everybody can make it out. And we've got our answer of 10. Right, so if I was to do it the old-fashioned way with a definition, I've entered start with 5 and 3. So this, my n is 5, my r is 3. Got my formula, the 5 over 3 there. You can see I'm replacing n by 5 and r by 3 with my wee exclamation marks. They're the factorials. And it just so happens that I did choose 5 and 3 before. So 5 times 4 times 3 times 2 times 1. Got that. On the bottom, I'll get 3 times 2 times 1 for the first part. 5 take away 3 in the bracket in the bottom is 2. So I'll get rid of all the brackets here. Just multiply them out and hopefully get 120 over 12. That looks nice to me. 120 over 12 is exactly 10. So if you follow those steps using the calculator, there, okay, just follow those steps, and you should get that. That'll probably take about 3-4 seconds. So instead of going through all of that, the motion there, okay. Right, so I think that might be a wee bit easier for you to do that. Okay, what do you think? I think personally I would go for that there. Right. Let's go back to the board. So use your calculator. Don't go through all that rigmarole there. So that choose function, it's going to be involved in this thing called binomial probability formula. So that's why we introduced it. So it's only one part of this formula which will help us work out our probabilities. So the big P on the left, it's a probability we're looking for. So you choose function, then choose R. It's getting multiplied by P. That's the probability of success. Then it's raised to the power R. That's your favourable number, the thing you want to harm. We then multiply it by the probability for failure, which we're going to call Q. And it gets raised to the power of the difference between the total and the number you're interested in. So that'll be N take away R, 2 numbers in the bracket. So that's our formula here. So A probability of win, Q probability of lose, and the probabilities of win and lose, they all sum up to give you 1. And because Q is involved in the formula, just using a wee bit of algebra there, that's actually calculated by subtracting P from 1. Okay, and I'll just showing you here, N is the total, and R, it's the favourable outcome, the thing we're interested in. So, there's your formula. We're going to go back to the Tommy pinball whiz kid example. What's the probability that he can win exactly 8 from a total of 10? So on the bottom line there, I put in all 4 values here. P and Q, that's my probabilities. 90% for success, that's why I've got 0.9. Failure, 10%, I've just decimalised at 0.1. Let's go for it. Probability of 8. So that'll be N choose R, so that'll be 10 over 8. Okay. We're timesing that by the probability of success, which is P, which is 0.9 to the power of our favourable number. We're then going to multiply that by the probability of failure, which is 0.1, and we raise that to the difference between the 10 and the 8. Okay, so we're then ready to get the calculator. Let's see the 10 over 8, the choose function. I'll just write that the way it comes up in the calculator. Okay, so that's fine. And then times 0.9 to the power 8. Make sure you can find your power function in your calculator. And 0.1 to the 2. So you should be able to fire that into your calculator and hopefully come up with some answer like that. 0.19371 in this case. Check that the answer lies between 0 and 1. Okay. So, if it doesn't, then you might have made a wee mistake, because all probabilities lie between 0 and 1, unless we say differently. Okay, so what does that number mean for us? Can we get a handle on it? Well, I'm saying that's approximately 0.2. That's what those 2 squiggly lines mean, approximately. So 0.2, it's actually exactly 1 over 5. So I can get a handle on that. 1 over 5, 1 out of 5. So Tommy has a 1 in 5 chance of winning exactly 8 out of 10 games. Well, you might think, well, that's not very good, since Tommy has a 90% chance of winning 1 game. But the thing is, folks, we're saying exactly. He could have won more, could have won 9, he could have won less, he could have won none. Right, so that was his probability of winning exactly 1 game. So I'm going to leave it there, and we'll come back to Tommy, and we'll change the question ever so slightly. So I'll be back soon.